So today we kind of revisited the graphing with Desmos, so you know that that's available to you on all your unit tests, just not on your state test. So on your state test, if you want graphing capabilities, you can get a graphing calculator. I've never really graphed an inequality on a graphing calculator, but you can look up a YouTube video with whatever model calculator you have and figure it out. But for the unit tests, you will have access to graphing calculators, and they do have all the buttons for the inequalities. So as far as shading above or below, dashed or solid, like that can be kind of like a cheat sheet for you. But if you don't know how to make it from a situation, then what's the point of it? You have to know what sign to pick if it's a word problem and things like that. So that's what we're looking at today. And we did a couple examples, but we need to do, I think, the two more that are on your notes, kind of as a warm up before I let you work on this. So if you could take out your notes from algebra, whatever hours that was. We're just going to do the two examples that we didn't do. I think in some classes I went by like really well. The first examples, and in others they took like a really long time. But you're all here to know. We're going to do a new situation. So again, this is in your notes from today, lesson 23. What we did. We're going to do these together. So we have two kinds of tickets to an outdoor concert were sold, lawn tickets and seat tickets. Fewer than 400 in total were sold. And then it asks an additional question. You can kind of ignore the additional questions right now. It says, if you know exactly 100 lawn tickets were sold, what can you say about the number of seat tickets? We'll get to that later. For now, you just need to be able to make the inequality. So identify a total or a constraint. Same difference, to be honest. Table 6, can you tell me the constraint in this? Table 6. 400. So 400. And normally, like, we are separating the unit tests into equations and inequalities. Like we already took the one on equations, so you know this is going to be an inequality. But normally you have to determine that yourself. So look at the words are surrounding the 400. It says that fewer than 400 tickets were sold. So think about what that means. We can come to the expression later. So like, I guess for right now, I mean, I wouldn't write this down. But we could put like tickets actually sold on this side. We'll make an expression for that soon. But can what we actually sold be greater than 400 if fewer than 400 tickets were sold? No. So then I'd have to flip the sign. So if fewer than 400 tickets were sold, can what I actually sold be less? So is it facing the right direction now? I'm not asking just one of you, I'm asking all of you. Yes. Can I sell exactly 400 tickets if fewer than 400 tickets were sold? So no little line underneath this sign. It has to be that symbol related to the 400. Now we need an expression for what the tickets were that we actually sold. So you read your sentence. It says 2 kinds of tickets to an outdoor concert were sold. Lawn tickets and seat tickets. Fewer than 400 tickets in total were sold. So table 8. What expression can I write for the tickets that were actually sold? Okay, we can add them. And do we know how much of each? Okay, so this question is separate. Right now, we're just making like a general inequality. So kind of ignore this part. We don't need this part yet. I know that's confusing. I'll fix the note sheet for next year, but there's not much I can do about it for sure. Anyway, do I know how many of each they're selling? So those are my unknowns. Those I should probably use variables for. If we're graphing, what variables do we recommend? So we can make X the lawn tickets. So the number of lawn tickets. And we could make Y the number of seat tickets. And that's an A, number of. Because you do need to define your variables. All right, and that makes sense. All I would have to do is count how many I sold of each, and we know that fewer than 400. Questions on that? Okay, so now we're going to graph it. And you are allowed to use graphing technology. Like today, the skill that we were practicing is actually not graphing, believe it or not. It's about solving, it's about making the inequality and then solving it. The only way to solve it is by graph. So you can use technology to do that. With technology, you don't have to put it in slope-intercept form, but it actually wouldn't be hard to put this in. So that's what I'm going to do because I don't want to pull up this right now. You all could. That's easy. Table 9, though, can you tell me what I would have to do to make it slope-intercept form? Make it louder, don't be scared. Subtract the X. Okay. Because that would isolate the Y, and then it would be in slope-intercept form, which is what I'm going to use to graph from, which I don't feel like, but you can. This is it in slope-intercept form. Questions on that? All right, so table 4, what's my y-intercept? 400. You guys can label your tick marks however you want. I mean, there's certain things I would recommend, but it just needs to include the 400. So class, what should I count these tick marks by? Okay, 100s, 50s, up to you. I kind of like 50s because then you can spread it out more, but it really doesn't matter. You can do 100. It just needs to include your right. This is fine if you want to do that. My y-intercept is 400, so I put a dot there. You should probably label like what this represents. What did we say our y-axis is? Or our y values are? They're the number of seat tickets. So, if you want to do it. And then X was the number of lawn tickets sold. If you want to be able to use your slope, because these are big numbers, like they're not super user friendly. If you want to be able to use your slope how you normally do, first, table 1, can you tell me what the slope is? What's the slope? Not 1, but -1 over 1, yes. So if you want to be able to go down 1 to the right 1, like how you normally do, then these need to also be going up by the same amount. So if these are going up by 100, and so do these. Otherwise, like it's not impossible to do it another way, but okay, anyway. So yeah, you can go from your y-intercept down 1 to the right 1, down 1 to the right 1, until you have enough to make a straight line. Before you draw your straight line though, you have to ask yourself now, should it be solid or dashed? So table 2, based on my symbol, should I have a solid line or a dashed line? Yeah. If you've already made it solid, then fix it, because it should be dashed. And also with inequalities, we either shade above or below. So table 6, based on and there's lots of ways you can tell. You could graph it in Desmos. You could look at your symbol. You could think about it logically. Table 6, if fewer than 400 tickets were sold, should I shade above or below? Good. And again, you can check all of those 3 things I told you. The rule, the Desmos, the critical thinking skills, we shade below because that's what is fewer than 400, right? Okay. Also in these, we identified a solution. There's lots. Even though it doesn't look like a lot, there are lots. Chris, tell me one solution and then I'll let you go to the rest of them. 100, 200 is in the shaded area, so it is a solution. Table 2, tell me another. Okay, also in the shaded area, also a solution. If it were on the dashed line, would it be a solution? No, not for this, because it's fewer than 400. So if it's 400, it can't be that. All right, so if we go back to the additional question, if you knew that 100 lawn tickets were sold, what can you say about the number of seat tickets? What's the most seat tickets they could have sold at? I'm asking all of you. So we know they sold fewer than 400. If 100 of them were lawn tickets, then they sold how many seat tickets at most? Sorry, one more time. Technically 299. Because it's fewer than 400. We don't want it to be 400 exactly. So they sold 299 seat tickets or less. Because it can be less. We don't know how many. It said fewer than 400. So it can't be 400 exactly, it can be 399 or below. 100 of them are lawn tickets and 299 tickets. Good, any questions? Getting better, maybe? Okay, we won't drag this next one out, I promise, it'll be quick. But there's one more, the last one. Okay, so same situation, but we're not like layering the 2 constraints. This is a new constraint. Ignore this part, we don't need this part. That's just like an additional question. So if lawn tickets cost $30 each and seat tickets cost $50 each, the organizers want to make at least $14,000 from ticket sales. All I want you to do is make the inequality. That's all for this one. Don't need to graph it or anything else. Just make the inequality for this situation. Okay, who thinks we have the correct inequality? Last one? Okay, more than or equal to, can you give me the whole thing or? In one room. I heard 30 plus 50. Like on the side. Are we missing anything, class? Okay, because we don't know how much they're selling of each, right? And in the last problem, we did that X was the number of lawn tickets. And Y was the number of seat tickets. So let's try to keep it consistent. Let's not like switch it up randomly. So should it be 30y plus 50x, 30x plus 50y? Good. And did Massimo put the correct symbol? Like, is it facing the right way? If we want to make at least 14,000, can we make more than that? Can we make exactly that? If it's at least. So then this is perfect. Great. Graphing it, you can graph it if you want to, but the making it is the key thing. That's what's hard. That's what we're practicing. All right. Questions, comments, concerns? All right, so you have the practice for today. Hopefully that makes it a little bit easier and we'll get you more things right when you take your actual tests. If you need help as you go, do let me know. I'll check in like the last 15 to 20 minutes. Number 6 on today's practice. A store sells notepads in packages of 24 and packages of 6. The organizers of a conference needs to prepare at least 200 notepads for the event. Graph the solution set to the inequality, then use the graph to determine other possible combinations of large and small packages of notepads that will meet the number of notepads needed for the event and select all that apply. Okay, so kind of a beefy question. We know that they need at least 200 notepads. They have variations of packages, but we know they need at least 200. So that should probably be where I start. That's my total. That should be alone on one side. The phrase at least implies that it's going to be an inequality, and you have 4 options. For what sign to pick, just kind of play around with signs. If this will be what they are actually getting, can that be greater than 200 if we need at least 200? Okay. Let me say that again. If I need at least 200, can I have greater than? Okay, so not so far is the right sign. If it's at least 200, can it be exactly 200? Yes, at least does include 200 itself. So that's how I do it. If it can't be greater than, then I just switch the sign. Give the first. And then I say, can it be exactly that? And that tells me if I have the line underneath. For the expression that goes on the other side, that probably has to do with this information, that we sell them in packages of 24 and packages of 6. Do we know how many of each we are getting? Do we know how many packages of 24 we are getting? Like, does it say where I am getting 10 of these ones? Where did it say that? It doesn't say it, right? It doesn't say we're getting 10 of the packages that come in 24. Like, it doesn't say that. So, you don't know that. That's an unknown. How do we label unknowns in math? So, what should I write for an expression that uses these numbers and accounts for the unknown? What could those be? You guys are just waiting for me to tell you the answer. I'm not done. Okay, great. That is something I can actually graph down. And it was 24x plus 6y greater or equal than 200. All right, so that is now graph. And the way that we have it, we have S is the larger packages and Y is the smaller, which is important to note because when I'm reading it, I need to be able to translate it to this. If this is 5 large, 5 small, the coordinate would be 5, 5 that I'm seeing. Is it in the shaded? Is it on the solid line? See if it's a solution. For this one, it would be 5, 8, 5, 18, and so forth. So however you set it up, if we're saying this is X and this is Y, then that's the coordinate I need to look for. So for all of those points, I'm going to see, is it in the shaded area or is it not? Or is it on a solid line or is it not? So 5, 5 is marked by that dot. Is that going to be a solution? But don't pick that one. And basically you're doing that with all of them. 5, 8. Is that in the shaded region? Pick that one. Do you need to see the rest or? If not, let me know. But this is the one that goes with this problem, that inequality. So graph it, see if these fall in that shaded area. So far we've excluded the first two. Of course, there might be a couple. Check the rest and then you can come back to it if you need to. Okay. Let's see. That one we should for sure pick at least. The others. That one. And we'll check the last one. But hopefully you guys could do this yourself. It's too with your own inequality if you have to make from scratch. But yeah, that's how you do it. Questions on that one? Questions on others? Amy? Please. All right, number 3 on the substitute. Okay, so Elena is ordering dried chili peppers and corn husks for her cooking class. Chili peppers cost this much per pound, corn husks cost that much per pound. Elena spends less than $50 on D pounds of dried chili peppers and 8 pounds of corn. Here's a graph that represents the situation. So which inequality represents it? And then we're answering some questions. So if this is my graph, to translate it from this to here, I'm probably going to look more toward the words because it's hard to do it from the graph when these are not in slope intercept form. So I'm going to do it based off the real world situation, and specifically the what seems to be different here is the sign that they're using. Everything else is the same except this sign. So it looks like there's debate on whether or not it can be the 50 exactly or it cannot. Based on the graph or based on the situation, if you want to reread it, she spends less than 50. Should I use the symbol without the line underneath it or the one with the line? Inequality A or inequality B? A because it's a dashed line. And because it said less than. Let me check again. Yeah, she wants to spend less than 50. So that means it can't be the 50 exact. So inequality A for sure. Can she purchase 2 pounds of dried chili peppers and 4 pounds of corn husks and spend less than $50? So let's look at that on the graph. So 2 pounds of the dried chili peppers would be here. 4 pounds of the corn husks would be there. So can she buy that combination? And it's because it's not in the shaded area, and it's also not on the solid line. So you'd say no, and that should be having parentheses. So know your coordinate should have parentheses, but it says the 0.24 is not part of the solution region shown in the graph. It's not in the shaded area. Then it says, can she purchase 1.5 pounds of the dried chili peppers and 3 pounds of the corn husks and spend less? Let's see. 1.5 of the dried chili would be here-ish. 3 would be there for the corn husks. So can she buy that amount? Yeah, because it is in the shoe. So yes, because that coordinate is part of the solution of this one. I'll have to edit it and it's so it looks like the true coordinate because we both use points or write it as a coordinate B for you, but I guess it is lost of it. Okay, questions on that one? We might have time for one more. We don't have to work to do. On this one? Okay. So a store sells notepad packages. We did this one earlier, but it's adding on to it. So would they have enough notepads if they bought these quantities? So this is kind of similar to what I showed you when we graphed it. You need to now see, like, if this is on my x-axis, the large packages, and this is on my y, you're checking for this coordinate now. Oh wait, hold on, I'm messing it up. What's hard about this one is they put it in words. So you're actually looking for the coordinate 7, 1, because it's 7 packages of the large one and 1 package of the small one. And then you're checking for 5 packages of the large one, 15 of the small. And then complete the following. Oh, and then what symbol you could use? Which, if they need at least 200, you said that they should use that. So you guys yourself will just have to draft this and see those percentages. All right, I think that's it. So if you have any other questions, email me. Ask me another day. Tomorrow in math lab, you'll have some Excel skills.
So it's gonna change. Was
Nothing
has changed. How many years? 6?